Hello everyone, we're team 676. We're all double E students. My name is Zoe Peche. This is Sylvia Redondo, Corbin Kovacs, Mallory Brando, and Michael Martin. Together with our sponsors, Simple Biomedical, we've been working on a project called Smartwear. What Simple Biomedical envisioned as their end product is a wearable full-body motion tracking suit that can be worn while exercising or while doing physical therapy or even throughout your normal day. The final product will send Bluetooth data, will send motion data via Bluetooth to a phone application where it'll be digitized and turned into humanoid figures so that the user can view it in real time or even rewatch it later. And this could have countless applications. For instance, athletes could use it to review their technique and improve their form later on, or physical therapists could monitor their patients remotely so that they wouldn't have to leave their home and could practice at a much more affordable cost. So what we were tasked with doing was basically collecting data and sending it via Bluetooth. And so our main goal was just to build a solid foundation upon which Simple Biomedical could further develop their product.
Our goals for this semester include having a valid proof of concept to deliver to our sponsors. For this proof of concept, the team will provide extensive documentation as well as the schematics for the motherboard and daughterboard. These items are necessary for Simple Biomedical to build and develop the next iterations of footprints and PCBs. Another of our goals was to collect raw data from each MPU 9250 daughterboard and have this data be transmitted via Bluetooth Low Energy 4.1 to an Android phone application. The team has developed a firmware to go with a basic prototype which consists of the MPU 9250 and the Max 32630 breakout boards wired together. For our final goal, we want to have each IMU program with a unique ID and have each data packet be timestamped before being delivered via Bluetooth. The timestamps and the ID will help prevent errors such as out-of-order data. After we define our goals, the team moved on to research and design.
So in our research and design, we spent a lot of time looking up all the different components that are on the market, comparing specifications and trying to figure out which ones would be best for us. So we already mentioned that we're using the Max 32630 for our microcontroller. The IMUs that we chose is the 9250s, and those are a 9-axis sensor. And currently we're using the Panasonic 1326B for our Bluetooth radio signal going out. Basically, we can use our microcontroller. It uses SPI or I2C for its protocol. For the serial data bus, we chose SPI just because I2C is very limited on distance and number of masters and slaves that you can have. Our microcontroller, it operates at 1 megahertz in the SPI protocol, and we're sampling 3 bytes of data per axis on each one of our sensors every 20 milliseconds. And then we're transferring that with the Panasonic at a rate of 50 hertz, I believe, is that correct? 50 hertz. And then we also used Altium for our designs and prepared our PCB schematics. And we'd love to open this up for any questions that you may have.
Yeah, so how many sensors do you typically have around this hub, typically on a person? One for each arm, leg, what?
The way that we designed it, we have 3 masters, and each one of those masters has 7 slaves, so we could get up to 21 sensors.
So all those slaves have a battery?
We have 1 battery for the entire component.
For everything?
The entire design.
Okay, so they're all hooked together by wires. So
Yes.
Okay, all right.
Yes, sir.
So you got wires running everywhere to get the other. Okay. So you have to sew them into the wires into the suit or something, or tie them on or something.
Right. Long term, they would want to put them like inside the clothing.
Okay. All right. So how long, given it battery, how long do you expect to get out of a battery before you have to change it?
There's a number of variables that could be involved there, just depending on size of battery, just to start. And
for our prototype, I think we did 4 to 5 hours just for the prototype.
Okay.
How many sensors, how many hubs in that prototype?
So the one we have, for the calculations, I think we did 21, but for our actual prototype, we have 6. So our battery should last for a while for the prototype we have now.
6 sensors
6 sensors,
and 1 hub?
yes.
Okay.
Any more questions? Then we can thank the team.